the products of electrolysis depends on the different oxidizing and reducing species present in the electrolytic cell and their electrode potential. Now, the reaction with higher reduction potential is preferred, and hence the reaction at cathode will be that of the hydrogen. For dilute sulfuric acid, the first reaction is preferred, but at higher concentration of sulfuric acid, the second reaction will be preferred. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with session 4 of the chapter Electrochemistry. So in the last section, we discussed about the thermodynamics of Nernst equation. That is how we can relate it with the thermodynamic equations, right? As well as we started off with electrolytic cell. So in today's session, we are going to study with the products of electrolysis. Okay, so we already have studied about what is electrolysis. So depending upon the electrolyte which is present, we are going to get different types of products in the electrolysis. So regarding that in detail, we are going to study today. Okay, so let's begin our class with the products of electrolysis. So it depends upon the nature of material being electrolyzed and the type of electrodes being used. So what is the product which is formed, right? So we know that in electrolysis, what is happening? We are passing electricity through the electrolyte and some reactions will undergo, and maybe a product will be formed, it will be deposited, or else some gases can be liberated. All of this can happen. Now, which gas will be liberated or which is the product which is getting deposited, it depends upon which electrolyte is being taken and which is the electrode which is being used, right? Now, if the electrode is inert, it does not participate in the chemical reaction and also acts as a source or sink of electrons. Now, from here itself you can say inert electrode, right? The electrodes if you are using, if it is inert, that means it is not ready to take part in a reaction. So what happens? Of course, then it doesn't make any difference in the product which is formed because it itself is not taking part in the reaction. Now, if the electrode is reactive, it participates in the electrode reaction. So if it is reactive, it participates in the reaction and hence it also plays an important role in the determination of the product formed, right? Now, the products of electrolysis depends on the different oxidizing and reducing species present in the electrolytic cell and their electrode potential. So basically the products formed, that is, it can be liberated, right, in the form of gases, or the products being deposited in the anode or cathode, depends upon which is the electrolyte we are using and which is the electrodes which is present, right? So if it is inert, it does not have a part in that. If it is reactive, yes, the electrode which we are using also plays an important role, right? Now, some of the electrochemical processes, although feasible, are so slow kinetically that at lower voltages these do not seem to take place and extra potential has to be applied. Now, some of the electrochemical processes, although feasible, that means yes, the electrodes will be reactive. Yes, the reaction can proceed, but still the reaction might be very, very slow, right? The reaction might be very, very slow, so that the overall voltage, right, the potential will be very less. In that case, we have to apply some extra potential. Okay, so these are the points to be remembered under product of electrolysis. That is, what is the product being deposited, liberated? It all depends upon the electrode and the electrolyte we are using, right? Now, let us start with an example which is given in your textbook itself. That is electrolysis of fused sodium chloride. Okay, so one by one, few examples we are going to discuss now. So first we are going to start with fused sodium chloride. Okay, now first of all, what is fused sodium chloride? Fused sodium chloride means it is in the melted form. That means that it is not aqueous sodium chloride. There is no water present in it. It is just sodium chloride only which is in the molten or melted form. I hope it is clear. So the products of electrolysis are sodium metal and chlorine gas. So now what is exactly happening here? So the electrolyte we are having here is the fused sodium chloride. There is no presence of water here. Only we are having sodium chloride. So what is going to happen here? The sodium plus Na plus ions is going to accept electron and form sodium, right? The sodium metal is being formed, right? So what is happening here? A reduction is taking place and Cl minus ions is going to oxidize to Cl2. That is, by the removal of electron, it is going to liberate chlorine gas. So what is going to happen? Chlorine gas is going to get liberated in the cathode and sodium metal is deposited in the anode. So you will be able to see sodium deposited on the anode and chlorine gas liberated at the cathode. So what is that? You have to remember the product of electrolysis of fused sodium chloride are just two. That is, the metal sodium will be deposited and chlorine gas will be deposited, because there are only two ions present, that is Na plus and Cl minus. One will undergo oxidation, another one will undergo reduction, and you will get sodium metal and chlorine gas. So this is regarding fused sodium chloride. Moving on to the next one, that is electrolysis of aqueous sodium chloride. Now what is aqueous sodium chloride? Aqueous sodium chloride means sodium chloride in presence of water, right? We have diluted it in presence of water. So now the problem is we have four ions here, that is from NaCl you have Na plus and Cl minus. Now aqueous means what? What is that we are adding? Water we are adding. So we have H plus and OH minus also there. So totally we are having four ions, two positive and two negative. Now what is going to happen is there is going to be a competition between these two positive ions and these two negative ions. So what you have to understand is, even though we have four ions present, only out of the two positive ions that you are having, only one can undergo the reaction, right? Or only one product can be formed out of those two. And out of the two negative ions you are having, only one of that can form a product. Okay, so there will be a competition between these ions. Now, how will we get to decide which is the reaction which is going to proceed and which is the product which is going to be formed? That depends upon the electrode potentials. So let us move on to this. During electrolysis of aqueous sodium chloride solution, the products are sodium hydroxide, chlorine gas and hydrogen gas. So you can see the difference here itself. What are the products formed when we are using fused sodium chloride? It is just sodium and chlorine gas. Here you are getting sodium hydroxide, chlorine gas and hydrogen gas. So let's see what is happening. In this case, besides Na plus and Cl minus ions, we also have H plus and OH minus ions, which is coming from water. Already I have mentioned this. Now at the cathode, there is a competition between the following reduction reactions. So what is going to happen? There is H plus as well as Na plus ions. Both of them will undergo reduction. So Na plus is going to accept electron and form sodium metal. Same way, H plus ion, which is coming from water, accepts electron and form hydrogen gas. It gets reduced to hydrogen gas. Now what we have to see, as I told you, there are two reactions which can happen in the cathode, but only one reaction can form the product. So how do we decide this? We are going to see the electrode potential or cell potential of this. So you can see the E0 cell value of, or E0 electrode value of Na plus accepting electron and forming sodium, that is minus 2.71 volt. And hydrogen, we already know the potential value is 0 volt, right? Now the reaction with higher reduction potential is preferred, and hence the reaction at cathode will be that of the hydrogen. So out of these two, that is minus 2.71 and 0 volt, of course 0 volt is the higher value, right? This is minus and this is 0. So what happens? The one, or out of these two reactions, whichever one is having higher reduction potential value, that will be chosen as the reaction which is happening in the cathode. So out of these two, which reaction is going to take place? This reaction is going to take place. This will not be happening because this is having higher reduction potential. We have already discussed this. Whichever is having higher reduction potential will be considered as the cathode. So this is the reaction which is going to happen. So we are going to write it as H2O plus electron. Why is that? H plus we are getting from water only, right? So H2O plus electron, what happens? You're going to get hydrogen gas which is liberated, and OH minus will be also there, right? H2O consists of H plus and OH minus, right? So what is happening? H2O accepts electron, that is exactly H plus which is present, and liberates hydrogen gas. So what did we confirm? That yes, in the cathode hydrogen gas is being liberated. Now moving on to the next part. At the anode, again two reactions are possible because we have two anions there, right? So chlorine ion, that is Cl minus, chloride ion, can oxidize to chlorine gas by the removal of electron, as well as water can get oxidized to oxygen gas by 4H plus and 4 electron by the removal of 4 electrons, right? Now again we are going to check the electrode potential of these two. We have plus 1.36 volt and plus 1.23 volt. Now the reaction at anode with lower reduction potential is preferred, and therefore water should get oxidized in preference to Cl minus. Okay, so here in cathode, how did we decide? Whichever is having higher reduction potential, that will be the cathode. Now coming on to anode, how we have to choose is whichever is having lower reduction potential, that should be our anode. So out of these two, yes, water, this reaction should be the one which is actually present in the anode, but there is a small problem there. However, on account of over potential of oxygen, the other reaction is preferred. There is an over potential which is developed within oxygen. Because of that, this reaction will not be considered and this reaction will be considered. So out of these two, actually considering the electrode potential which is having lesser value is this one, and that should be chosen as the anode. But as oxygen is having over potential, we are not choosing this one and we are choosing the first one as the anode reaction. So what happens? The net reaction will be, yes, in the cathode we have already seen we are choosing this reaction because of the higher reduction potential. Water accepts electron and forms hydrogen gas will be liberated. And same way in anode, what is happening? Cl minus ions get oxidized to chlorine gas. I hope it is clear, right? So what did we confirm from this? In cathode, hydrogen gas is liberated, and in anode, chlorine gas is liberated. Now let's write the overall reaction here. We have sodium chloride and water, right? That is NaCl in the aqueous state. NaCl plus water. So we have Na plus ion, OH minus ion, and then we have hydrogen gas and chlorine gas liberated, which we have already discussed. So we have Na plus and OH minus ions now. So that together can form sodium hydroxide. So what are the products of electrolysis of your aqueous sodium chloride? It will be sodium hydroxide, hydrogen gas and chlorine gas. Hydrogen gas at the cathode, chlorine gas at the anode, and sodium hydroxide will be present. I hope it is clear. So I hope the products developed in fused sodium chloride and aqueous sodium chloride is clear for you. In fused sodium chloride, you will have just the sodium metal deposited at the cathode and sodium metal deposited at the cathode and chlorine gas liberated at the anode, right? This will be the only products. But coming on to aqueous sodium chloride, you will have sodium hydroxide as well as hydrogen and chlorine gas. So why is the reason and how can we select which is the anode reaction and cathode reaction is clear for you. Yes, I hope it is clear, right? So only depending upon the electrode potential we are going to choose. Right. So what you have to remember, the higher reduction potential value, it will be chosen as the cathode. But in this case, the lower reduction potential one is even if it is this, it is not chosen because of the over potential of oxygen. Right. Moving on to the next one, that is electrolysis of sulfuric acid. Now during electrolysis of sulfuric acid, hydrogen gas is liberated at the cathode. So what is the product here? Hydrogen gas is liberated at the cathode. So what is the reaction happening at cathode? H plus ions accept electron and forms hydrogen gas. Right. Now at anode, what is happening? At anode, two reactions are possible. One is water can get oxidized to oxygen gas by the removal of electrons, or else the sulfate ions. Right. We are talking about sulfuric acid. So what is that you are having? You are having H plus ions as well as sulfate ions, right? So at cathode, what is happening? The H plus ions from the sulfuric acid is accepting electrons and forming hydrogen gas. So the reaction at cathode is only one, that is okay. Now at anode, the water can get oxidized to oxygen. That is, we are talking about aqueous sulfuric acid. And coming on to the next reaction, that is the sulfate ions which is present in sulfuric acid, that is also anion, right? So what can happen? It can form thiosulfate ions by the removal of electron. Now, which of the reaction will take place when? For dilute sulfuric acid, the first reaction is preferred, but at higher concentration of sulfuric acid, the second reaction will be preferred. So dilute sulfuric acid means more water will be present, right? So in that case, the one with the water will be preferred. That means at the anode, what will happen? Oxygen gas will be liberated. And in the case of higher concentration, that means lesser amount of water, what will happen? Thiosulfate ion will be formed. So this is what you have to remember. In the case of electrolysis of sulfuric acid, always the product which will be formed in the cathode will be hydrogen. No doubt in that. In the anode, what can happen? If it is a dilute solution of sulfuric acid we are taking, oxygen gas will be liberated. And if we are taking a concentrated sulfuric acid solution, what is going to happen? Thiosulfate ion will be formed. So this is what you have to remember, the products of electrolysis. So by this we come to an end to the discussion of products of electrolysis. So we have discussed 3 examples here: fused sodium chloride, aqueous sodium chloride, and the electrolysis of sulfuric acid. So in the next session we are going to discuss the conductivity of solution. So I hope the concepts we have covered in this session is clear for you. So that's all for today. Thank you.